So my name is Erik Bush. I'm the CEO and founder of Demand-Driven Technologies. We are a software provider for supply chain planning solutions. And you may be saying, well, what's that got to do with green? But there's a lot we can do, and I'll show you a chart here in a minute that I think will help get the point across that our supply chains can become much more efficient. And by that we mean we can eliminate a lot of waste, and if we do that, then we make ourselves greener in the process. So let's kind of dig in. I'm going to talk about kind of the opportunity statement that represents. We'll talk a little bit about the concepts that our software brings to life and why they're different than what the conventional software that's in the market is doing. And we'll talk about some of the benefits our clients have been achieving that you should be able to achieve as well. So let's talk about the areas where we can eliminate waste. And there are multiples. I mean, many of the companies here are on alternative technologies and things like that, but our focus is on making your supply chain more efficient and eliminating waste. So how can we do that? Well, every client we work with has inventory imbalances. They have too much of the wrong stuff, not enough of the right. And they focus a lot on expedited freight because they need to use that when there isn't enough of the right materials on hand. And so they have to air freight stuff in from Asia or take other drastic measures to get the materials so that their production schedules aren't impaired by that. That obviously is expensive. It often involves less efficient forms of transport. And so we are not helping ourselves when we are flying parts around the world to deal with imbalances. And so keeping your inventory aligned to where true market demand is very, very critical. When we look at clients that we've encountered, and that's over 120 clients around the world now, they are constantly facing this, what we call bimodal distribution. Too much of the wrong stuff, not enough of the right. So what can we do about that to make it more effective? Whenever we have too much inventory, we also need too much warehouse space. And I can't tell you how many, the whole third-party warehouse industry has grown up over the last decade or so because clients are frustrated with their inability to get inventory aligned right, so they need extra warehouse space. Oftentimes it's refrigerated space if they're in the food and beverage arena. That is highly inefficient. It's there because their material planning is not giving them the right signals. So now they're making an investment in extra buildings, extra energy to cool the buildings and maintain the environment within them. And obviously a lot of extra moving of material around in their supply chain environment, which involves freight and logistics. Too much obsolete inventory. Whenever we have too much, especially if we are sourcing materials from offshore, we tend to have this misalignment where because the lead times are so long, we're making orders today for things we think we're going to need 90, 120 days down the road based on a forecast and whatnot. And oftentimes that leads to obsolete inventory because by the time the material arrives, the products have moved on. The market's changed, there's been a shift, new competitors have come in, whatever, those circumstances get in the way of ensuring that we don't have excess and obsolete. And then obviously if we're a manufacturer, we're using materials and production resources, spending energy and people capacity to produce goods, which if they don't sell quickly into the market, we're wasting there. So you can let your imagination wander, and there will be many, many other thoughts you could have about areas where we've got leaks in the system, if you will, where we are utilizing resources inefficiently in a wasteful way. And if we can improve on those, then obviously we're going to be in a greener environment. To me, this chart is mind-numbing. This is a picture of U.S. manufacturers' inventory turnover rates over the last 25 years. 25 years. The 2.5 decades of primary ERP software deployment, right? You go back to the mid-90s, there was a land rush towards SAP, Oracle, and all these other systems because clients were tired of legacy software maintenance. They were tired of islands of automation. And oh, by the way, Y2K was on the horizon, right? So you saw this land rush into the ERP space. It's all in one database. We're going to maintain it for you, and it's Y2K compliant. So you would have thought, and I watched client after client while I was at IBM go down that path, convinced they were going to re-engineer their business around SAP, for example. And yet now, 25 years later, we're sitting at the same turnover rate for inventory, which is the primary, most basic measurement of inventory performance you're going to find in the industry. So how the hell is that after billions of dollars being spent here, we're not in a better arena? Anybody else see this kind of problem in your environment? I mean, we do statistics and analysis with every client we work with, and we see it time and time and time again. Yeah, there may be little blips of some progression. If you look in the middle of the chart, what's that period? That was the boom times of 2006, 2007. Then you see the crash, then you see COVID at the end of the picture there. So there's blips that obviously have taken us in the wrong direction, but suffice to say, we're not doing any better, which means that as an industry as a whole, there's a huge opportunity to make this a lot greener. Any questions on that? Okay. So why is that picture that way? There's a concept called material requirements planning. Who knows what MRP is? Come on, you're in manufacturing. Its premise is the following. If I know the demand, I will backward schedule all the things you need to buy, manufacture and assemble, package, and deliver to meet that demand. That's basically what MRP does. It's a big calculator, right? And that all sounds so very logical. And why do we have to do that? Well, we do it based on a forecast because our customers will not wait as long as it takes us to do all those activities to get their order fulfilled. So we have to start the system ahead of time. And the problem is that it's all based on a flawed assumption, which is that the forecast is accurate. If it's not, then all of those dependent activities that we're doing are going to be misaligned to what the actual demand is going to be. And this is really important because over the 25 years that we're talking about, one of the headwinds that we've been facing in the industry is product proliferation. We have more and more products to manage now, so it's harder and harder to get the forecast accurate. One of our clients, Michelin, tire business, right? In 1975, 80 timeframe, so a little bit before this picture, there were 10 sizes that made up 90% of the sales in US automotive tire sales in the US. By the time we get into this picture now, the top 10 sizes are less a third of the volume, and there's over 10x as many SKUs on the road. You just drive down the road today and you'll see so many different tire sizes. So what's happened is it gotten wider and wider. The volumes by SKU get smaller and smaller in relative terms, and that's why forecasting has gotten more and more difficult. So what can we do about that? Because from a user perspective, this is a quite complex environment. And the way I kind of liken it is that if I'm an MRP-based planner, I kind of feel like I'm one of the astronauts in the Apollo space capsule. There's a few of you that I think are old enough to remember what was going on back then. You may have seen the Apollo 13 movie. Literally at that point in time, the astronauts were part of the computer, the flight control system. Houston would call, hey, we need to now do this. And there would be a script of flip this switch, turn that knob, blah, 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 right? To keep a safe journey out to the moon and back. There wasn't enough battery life. Computers weren't very sophisticated at the time. Very difficult, very operator dependent, high degree of training. Only the best of the best of the best get to fly in those things. And obviously a very, very challenging environment. Most planners in an MRP environment are constantly fighting the system. Their role in many clients turns out to be check the math. Make sure you agree with what the system's telling us. And think about that. Is that what we want our people doing? Why can't that be more automated? I fly around the world all the time with my job. I'm going to South Africa next week. The pilot is rarely flying the plane. Hundreds of people on the plane. It's incredibly safe. Yes, there's been problems here and there, but as a process, it's unbelievably reliable. So why can't we get users more to that space? And I think we have to start challenging the assumptions, much in the way SpaceX is challenging a lot of the age-old assumptions in space travel. We need to do the same in a material planning standpoint. Our software and working with the methodologies is delivering results. The whole idea when we founded the company was that we were going to give clients a better result than that first chart I showed you. Inventory would go down, service levels would go up, your users will be happier. And our philosophy is that if we can do that well and reliably and consistently, we'll have a good business. Let's just make sure we put first things first, put the priority and the emphasis on our clients getting value. So they'll see improvements in on-time and full order fill rates, reductions in inventory, an easier to manage system, a compression of lead times, and other factors based on the concepts that our software delivers. It's a concept called demand-driven MRP. So whereas MRP starts with a forecast, demand-driven starts with the actual rate of consumption in the market. It's the most accurate signal we're going to find, right? So the question then is, how can we do that? Because if I wait till the order comes in, the sales order for that end item, how will I ensure that the material is available to ship, right? Because if I don't, then I got to go back to using a forecast and whatnot. And that's where kind of the secret sauce of all this comes together. And it's called the DDMRP buffer. By making this shift from forecast-based planning to actual consumption, we get a cleaner demand signal, and we get to better alignment of our materials to the actual market requirement, right? Let's use the most valid signal we can find. The way we do this is what's called a DDMRP buffer. It's an inventory position. And much like a Kanban loop is sized to deal with the rate of consumption in that Kanban loop, it's going to be based on a couple fundamental data elements. What is the lead time to replenish, right? And what's the rate of usage? That rate of usage is expressed as an average. That's what will go into the yellow zone. Our order point here is top of yellow. If we order at top of yellow and the lead time is achieved and the rate of consumption is in line with the sizing that we used here, the material will arrive at bottom of yellow. It's just a simple replenishment loop. But any one of you, I'm sure, will say, but that's not always going to happen, right? Your lead time may not be accurate, it may be delayed, the rate of consumption could be much higher. How do you protect against those? And that's what the red zone will do in a DDMRP buffer. And by buffering correctly, and actually instead of focusing on forecast accuracy, we focus on managing variation, we can ensure constant availability of the material. And if we do that, then we can go to a consumption-based system, right? So as long as we make this principle come to life, we're going to get better aligned to what the market's actually consuming. And that's kind of the whole idea behind DDMRP. The green zone is what we order on average. Typically, it might be a minimum order quantity. It could be an average batch size. There's a range of different parameters you may use for that. But that's your order up to. We order from top of yellow up to top of green. And so it becomes quite reliable. And I know it's going to be hard for you to see here, but there's a chart from the software that shows the inventory progression, the evolution of this buffer size, which is going to be dynamic and paced to the actual rates of consumption that material is experiencing. But it works. And it's so simple that pretty much any user can understand the mechanics of how it's happening. And buyers, as a result of that, then they start to understand that in fact, we don't have to be checking the math of the system. We can put ourselves more like that pilot and be an exception management role, looking for things that kind of deviate from the norm where we might need to get involved and take an action. So let's look at this in concept. This shows the zones dynamically changing over time. We have something called the net flow equation. This is the planning signal. And this may not sound like it's that important, but it tracks how is the ordering being processed. Too often we have customers who have a habit of buying double to stay out of trouble, meaning they'll look at what the system's recommending. Now, I'm going to lean into this one, right? Because they don't trust what's happened. And the consequence of stocking out is so much more severe than carrying the right amount of inventory. Plus, leadership doesn't know when it's happening. You really won't find out until much later down the road that in fact that planner's been taking that action. So we track that, and it's going to look like a sawtooth pattern like you see there. When we do that, the inventory line will progress and be kind of in the middle of the yellow, dipping into the red now and then. That's okay. The red zone's there to address the levels of variation that may occur in our supply replenishment lead times or in the rates of consumption. And this provides an incredibly useful visual element for users to start to understand that, yes, the system's doing what it's supposed to be. We're planning in ranges, so it's not so nervous like a typical MRP system, which is triangulating to a safety stock number for the item. And anytime anything changes, everything changes, right? So it becomes quieter, more paced. You're not ordering every day, you're ordering on some kind of an interval that the green zone helps you understand, and it gets us to a much, much better position. Our team is simulating this over in our booth. So as Chris mentioned, you can actually go there, fill in a demand card, and then tomorrow afternoon they're going to show you the simulation of this, how we can achieve incredibly high service levels without knowing what the demand's going to be, right? And if you get that idea, if you get this concept of constant availability, you can understand how we can pace to a more accurate signal. And there's a lot of other benefits that come with lead time compression and other, normalization of the variability that every supply chain experiences. So, talk for a minute about some of our success stories. This is why I'm going to Africa, by the way. Coca-Cola Beverages of Africa adopted our software back in 2019. They saw tremendous improvements in both raw and pack inventory reductions, improvements in finished good inventories, and their days stocked out went down dramatically. And the users found it much more reliable and viable way to plan. And we're going over to they've had some turnover through the COVID pandemic and things like that, so we're doing a little bit more training for the staff. But they've gotten phenomenal results. Barry Anderson, the senior executive that is running the program for Coke, has spoken for us. And it's just a great example how in a very, classic kind of food and beverage space, clients are getting much better results out of their DDMRP implementation than they were from an MRP standpoint. Another one is Michelin. Michelin now has over 50 plants deployed on our software around the world. They wanted a universal or kind of a standardized way of working for all the tire plants across their network. They saw improvements in inventory levels. They saw improvements in on-time order fill rates. They also saw a reduction in the amount of schedule changes. The buffering technique allowed their production schedule to be more stable, less frequent break-ins and things like that. So much more manageable kind of environment to be working in. So the key here, the secret sauce, is just use a better starting point, meaning that demand signal. Make it the most accurate signal you can find, and you will start to be able to align your materials to the actual demand out in the market. The buffers are ensuring that availability. It's not about managing forecast accuracy, it's about understanding variation. The more we understand variation, the better we can manage every part of our supply chain. This happens on the material side, but we also see the same thing with our production scheduling and execution platform. And all of this also leads to a much better and more manageable way of doing sales and operations planning, which we'll talk to here in a minute. And I can't also emphasize enough that clear and visible signals that we're giving, the users know what to focus on. It's more that exception management kind of thinking, like the pilot in the commercial airliner, who is really monitoring the system, but intervening when and if needed. This is just a quick view of some of the clients. You can see the effectiveness of the planning approach has crossed many different industry boundaries, everything from food and beverage to automotive to aerospace, heavy industrial, and others. I want to take just a second on this. So DDMRP is the starting point. It's kind of getting your materials under control. There's a concept called the demand-driven operating model over here on the left. That's the harmony between your materials planning element and your scheduling and execution side, because both of those have to work in harmony with each other. Too often we are doing things in materials that are ignorant about what's actually available on the production side or vice versa, and we harmonize those in what's called the demand-driven operating model. Now, I've been bashing the forecast. There is a role for forecasting in every manufacturing environment, and that's to understand what the future looks like. But it's not, and it should not be used for actually issuing orders against that forecast. What we do with what's called demand-driven S&OP in the middle there is we focus on identifying those exception cases. Where will the model be exposed, our operating model, our DDOM? Because if we understand those, we can adjust the configuration. Perhaps we need extra shift capacity. Perhaps we need to add an adjustment for a big promotion coming if you're in the beverage industry. There's also variance analysis that helps us understand how well has our demand-driven operating model been performing, and are there other adjustments? Do we need more coverage for types of variation that our planners are experiencing and the like? When you apply that in a classic S&OP fashion, it makes the process a lot more achievable. Many people have been around, I was in the middle of this at IBM, S&OP taken on steroids, you know, let's all hold hands, get a consensus demand plan, then we'll build a consensus supply plan, and we'll get everybody locked in, we'll get the executives to salute it, and by the time that all happens, everything's gone to hell because the assumptions that started that planning process are now no longer valid, okay? So try to give you a taste of what DDMRP and our software can do for you. Try to expose you to some different thinking around supply chain and how you can move forward in a much more pragmatic way. We want to get you in this the Dragon capsule, right? SpaceX sends 4 civilians up into outer space for 3 days on autopilot with some cool looking spacesuits and an iPad, right? Why can't we get closer to that in our inventory planning disciplines? Any questions? Come on. Yes, sir.
I guess as someone who works primarily in the electronics industry over the past couple of years, we've seen super long lead times on items like microcontrollers, you know, 60 to 80 weeks.
Yep.
How do you buy those based off, you know, demand feedback? How do you get around forecasts on some of those items?
Yeah. Great question. What do we do about supply constraints? I'm going to generalize the question a little bit because we're seeing it in electronics, we're seeing it in other categories of materials. The vendors will give you material. It's about understanding how much they can give you over a certain time frame. Because if you don't plan your materials with that limitation in mind, what you're going to end up is this scenario. How can it be that I'm in a supply constrained environment, yet my inventories are still going up? And the reason is that in the bill of material, there's 1 or 2 components that are not available, but we keep ordering the rest because the forecast looks so good. We got all this back order demand to fill and now. So you have to shift your focus to more of a supply-based constraint and planning accordingly. And so you're gonna size your buffers accordingly. You're gonna feed it a different signal than you would otherwise. I'd be happy to talk with you offline about that, but there's a number of tactics that we're using with clients to address that very scenario. Other questions? Yes, sir.
Is your service an add-on to something like SAP?
Yep. So it's a complementary solution. Our biggest client base is the SAP community, but we've implemented with probably 30 different ERP companies or platforms around the world. It's hosted in Microsoft Azure, so it's all in the cloud, fully data security compliant and certified, very easy to add on to an existing environment. And it preserves the investment in your ERP, but gives it functionality that it doesn't have today. Anyone last question? Thank you so much for your time and attention today. Really appreciate it.